So we continue with the problem 59. A 20 kilogram block is connected to a 30 kilogram block by a string that passes over a light frictionless pulley. So here is the pulley, and you have, this is the light cord, and this cord, it connects these two blocks. The 30 kilogram block is connected to a spring that has negligible mass and a force constant of 250 Newton per meter, as shown in the figure below. The spring is unstretched when the system is as shown in the figure. So in this position, the spring is unstretched. And the incline is frictionless. So both the incline and the pulley are frictionless. This cord is light, and this spring, as shown in the figure, is unstretched. What happens is the following. The 20 kilogram block, اللي هو الصغير هون, is pulled 20 centimeter down the incline. So this was pulled 20 centimeter so that the 30 kilogram block is 40 centimeter above the floor. طيب بما انه هذا البلوك was moved 20 centimeter بهالاتجاه هيدا down the incline. What happens with the other block? بما انه هيدي الكيبل هو عباره عن light cable, منه elastic, it passes over a frictionless pulley, so the tension in the lightweight cord is the same. That means that the block 30 kilogram will move up in the same way by 20 centimeter. So مثل ما كنا نحكي بالchapter number 5 and 6, that if you have two blocks connected by a lightweight cord or cable that passes over a frictionless and massless pulley, if the first block moves by a given distance or displacement delta x, the other block will move by the same displacement. وهذا الشيء بيعني انه بالفاينل ستيت اللي راح يصير هو انه يعني بعد ما نعمل هذا الشيء البلوك الثاني اللي هو 30 كيلوغرام it will be in this position, okay, and the spring will be stretched بهالشكل هيدا. اوكي وبالتالي بيكون 4 سنتيمتر اعلى عن الهوريزونتال لاين. So it's 30 centimeter. So the 20 kilogram again block is pulled 20 centimeter down the incline so that the 30 kilogram block is 40 centimeter above the floor and then released from rest. So شدينا لهيدا البلوك 20 سنتيمتر وبعدين فلتناه. You have to find the speed of each block when the 30 kilogram block is 20 centimeter above the floor. That is when the spring is unstretched. شو بيصير عمليا؟ خلينا نطلع على هول الرسمات. طيب هون كان initially كان مثل ما الرسمه كانت موجوده عندنا، كان في عندنا البلوك سميته ال 20 كيلوغرام سميته M1 وال 30 كيلوغرام سميناه M2. هيدي الرسمه مثل ما كانت. شو عملنا نحن هون يلي صار؟ مشينا هيدا البلوك M1 by a distance D down the incline. بالنتيجة طلعت هالبلوك 2 a given X upward. But actually we should not forget that this X is nothing else than the D. لأنه هون given الشيء اللي حكيناه قبل شوي, the displacement done by the block M1 is equal to the displacement done by the block M2. الM2 عمل displacement D، بس ما انه الM2 مربوط بالسبرينج، فالسبرينج شد معه. قديش شد هيدا السبرينج؟ هي نفس المسافه اللي مشيها اللي هي D. So this is why the elongation X is given by D. وبعدين فلتناه، فلما فلتناه شو بده يصير؟ البلوك M1 حيمشي يرجع بالاتجاه المعاكس بسبب انه هون السبرينج عم بشد البلوك لتحت بسبرينج فورس البلوك M2. فبالتالي البلوك M2 رح يرجع يمشي upward والبلوك M2 حينزل نزول. السؤال هو لما البلوك M2 يرجع يقطع بالاكوليبريوم بوزيشن الاساسيه اللي له اللي كان هون، اوكي، لما يقطع على هالنقطه قد ايه بتكون السبيد تبعيته، وبهالوقت هيدا قد ايه بتكون تلقائيا السبيد تبع البلوك M1. So how much is the speed, or how much is the speed of each block when the 30 kilogram block is 20 centimeter above the surface again, or above the floor again. طيب Of course, we can solve this problem using Newton's laws of motion, and in particular, Newton's second law of motion. However, not going to be quite easy. هلا طبعا منا صعبه بالنهايه، بس given انه احنا فينا نستخدم ال principle of conservation of energy، اكيد اسهل نستخدم هيدا الابروتش على انه نستخدم نيوتن's second law approach. So this is why we are going to use the principle of conservation of energy approach. Let's check if we have non-conservative forces acting in this system. So we have, first of all, a frictionless pulley. We have a frictionless incline. So there are no non-conservative forces acting, and in particular يعني friction force. Friction is not present in the system, and so we have conservation of mechanical energy. So the mechanical energy in the initial state is equal to the mechanical energy in the final state. Now, before to start, we will have to precise and to specify which are the initial and the final states. نحن بالنهاية بالفاينل ستيت بدنا نكون بهالنقطة هيدي لما يكون البلوك M2 لما كان 20 سنتيمتر above the floor نازل بسبيد معينة let's call it V2، ولما بهالوقت كان البلوك M1 طالع بسبيد معينة سميناها V1 right؟ طيب بما انه السيستم او بالاحرى البلوكس M1 and M2 they are connected through a cable that passes over a frictionless and massless pulley. Okay, هذا الشيء بخلينا نقول انه the speed of the two blocks is the same. يعني speed V1 is equal to V2. So both blocks they are moving with the same speed لأنه اثنيناتهم they did the same displacement. And so let's actually expand this expression for mechanical energy initial and final. Given that the initial state is when the block M2 was pulled a distance d downward, and the final state is when the two blocks are moving with a speed given by v. So let's start initially. K initial هي كانت صفر لأنه the system was released after the block 2 the block 1 was pulled، فبالتالي هي صفر. يبقى عندنا ال potential energy elastic and gravitation in the initial state is equal to the kinetic energy in the final state plus the potential energy in the final state including both gravitational and elastic. طيب هون دورنا نحط كل شيء بقيمته. قبل ما نحط كل شيء بقيمته فصلتهم شوي حتى نقول انه this potential energy for the gravitational force it includes potential energy for the block 1 and for the block 2. The potential energy هي للspring, and then also in the final state the kinetic energy it is composed of two terms اللي هن potential or kinetic energy for block 1 and kinetic energy for block 2 ونفس الشيء بالنسبة للpotential energy هي for block 1 and block 2. And finally the potential energy for the spring USF. هلا هون حطينا كل شيء بقيمته. ال M1G Y1 initial plus M2G Y2 initial plus half kx squared بالinitial state ما ننسى كان ال spring stretched by how much? By x we called it. So the elastic potential energy was half kx squared. And then in the final state we have both blocks were moving with M1 V squared over 2 for kinetic energy for the block 1 and M2 V squared over 2 for the kinetic energy of the block number 2. M1G Y1 final for U1 F, M2G Y2 final for U2F gravitational, and then in the last or in the final state the potential energy the elastic potential energy is equal to 0. ليش؟ لأنه الوقت اللي عم نطلع عليه هو لما كان البلوك 2 at 20 centimeter above the floor. يعني لما كان ال spring بهالحالة unstretched فبالتالي there is no elastic energy that is stored in the spring. So this is why USF is equal to 0. So let's put together all the terms. We end up with M1G times Y1 initial بنجيب بنحطها مع YY final لأنه هول two terms عندهم M1G in factor in common plus M2G Y2 initial minus Y2 final plus half KX squared is equal to half M1 plus M2 times V squared. Now if you make the numerical application given that Y1 initial minus Y1 final you will see that it's equal to minus d sine theta y2 initial minus y2 final is equal to x, we will end up with v equals 1.24 meters per second. Now, just one note or one comment about how did we evaluate this difference in the elevation for the block number 1 and the block number 2. طيب خلينا نبلش بالبلوك نمبر 2 لانه اهين. البلوك نمبر 2 بالانيشال ستيت كان عالي، كان فوق، وبعدين فلتناه فرجع نزل لهالبوزيشن هاي. فاذا الواي 2 انيشال كانت بهالبوزيشن والواي 2 فاينل هي الاكويليبريم بوزيشن. So y2 initial minus y2 final is equal to x, right? This is nothing else than x, and x is simply d. اما بالنسبه للبلوك m1، طيب البلوك m1 كان initially in this position. لما كنا بدنا نفلته كان هو نازل بعد distance d لتحت. So هيدا الانيشال position. This is y1 initial. And then in the final state البلوك 2 كان already مشى distance d. So عمليا كان وصل على هيدا البوينت هي. So how much is delta y in this case? Look, y1 final minus y1 initial. هل طلعوا على هاي triangle هيدي هي delta y, right? So if you just apply the trigonometric definition of the sine theta or trigonometric function يعني sine theta, it's given by the opposite على hypotenuse. So delta y opposite hypotenuse d. So we end up with delta y is equal to d sine theta. هيدي y1 final minus y1 initial. بس نحن عندنا y1 initial minus y1 final, so we have to include a minus sign here, and so finally we end up with the final result given by 1.24 meters per second. So this is it for this problem. We'll move on to the last problem, number 61. A block of mass 0.5 kilogram is pushed against a horizontal spring of negligible mass until the spring is compressed a distance x, as you can see in this figure. So we have a block of mass m, you compress, you push it against the spring, and the spring is then compressed by this distance. The force constant of the spring is given by 450 Newton per meter. When it is released, the block travels along a frictionless horizontal surface to point B in here. And so this point B is the bottom of the vertical circular track of radius 1 meter. And then it continues, the block, it continues to move up the circular track of this radius. The speed of the block at the bottom of the track is given by VB equals 12 meters per second. And the block experiences an average friction force of 7 Newton while sliding up the track. So طلع على التراك، بس هو طالع على التراك كان في friction force عم تعمل action عليه which has an average value of 7 Newton. First of all, you have to determine how much is x, how much is the compression of the spring. Then what speed do you predict for the block at the top of the track? And finally, does the block actually reach the top of the track or does it fall off before reaching the top? So let's start with solving this problem. أول شيء, how much is x? The determination of x is not that difficult because we know that when we release the block in this position, it arrives at point B with the value of the speed given by VB equals 12 meters per second. And we know that from this position up to point B, we had no friction. So we have conservation of mechanical energy of the block. So let's apply the conservation of mechanical energy of the block between initial state and the final state. The initial state it corresponds to the time when the block was released, and finally the final state is defined at the point B. طيب بما انه بكل الاحوال between initial and the final state the block is always at this horizontal surface, so there is no variation in the gravitational potential energy of the block. And this is why in this equation the gravitational potential energy is reduced on both sides لأنه هي نفسها ما تغيرت. بالنسبة للinitial state الكاينتيك energy كانت صفر، أما elastic energy كانت half kx squared. هيدي هي قيمة البوتنشال energy اللي كانت stored مخزنه بالspring. And in the final state كان الspring بقى صار in unstretched position and uncompressed position as well. It was in equilibrium. So this is why U spring is equal to 0. بينما الفاينل K final kinetic energy was different than 0, of course. It was equal to half mvb squared. So we reduce half on both sides. We end up with x equals square root of m divided by k multiplied by vb, and that gives the value of 0.4 meter. So this is it for the first part. Now, what speed do you predict for the block at the top of the track? طيب علما انه انتم بتعرفوا كل شيء now about this block. بتعرفوا انه هو كان بهالنقطة with a speed equal to 0 but with a given elastic potential energy. At the point B, it has the speed VB. What speed do you predict? إذا البلوك حيقدر يوصل لأعلى نقطة، قد إيه حتكون السبيد تبعه على أعلى نقطة؟ علما إنه on this circular track you have a friction force that is acting. So you have one non-conservative force acting on the block. طيب نحن شفنا already بالcourse إنه whenever you have a system where you have non-conservative force acting on it, we saw that the variation in the mechanical energy is given by the work done by this non-conservative force. And delta EM is equal to WNC. So in this case, we can say between point B and point T, the variation of the mechanical energy is nothing else than the work done by the friction force, right? And since the friction force is constant, so we can say that WF is equal to integral of F dot dr. مزبوط انه الاف كونستنت بهالحاله، بس الدي ار منا واضحه، يعني هي عباره عن half a circle. ما فينا نحطها بس مجرد دلتا ار مثل ما بنعمل بحاله الكونستنت فورس when it implies or it provoke a rectilinear displacement، يعني displacement along a straight line. لا بهالحاله نقدر نكتبها بهالشكل، الاف دوت دي ار، الاف تطلع لبرا لانه هي عباره عن constant، بس بيبقى في الانتجرال للدي ار. So let's do it. So we know that delta EM is equal to WF. How much is WF? Is the integral of F dot dr. إذا بتاخدوا حيلا نقطة، إذا البول هي ماشية طلوع، displacement تبعها هو بهالاتجاه، بينما الفريكشن هي بالاتجاه المعاكس. Both vectors are tangent to the circle. So the scalar product between these two vectors, it gives minus F dot dr. And since F is constant, احنا الF معنا اياها constant، بس هو قال لي the average value of the friction force. يعني عمليا انا عم باخذ انه هي بكل الاوقات كانت equal للaverage value. This is what it means. The average value of the friction force is given by هالقد وهالقد. So minus F بتطلع لبرا، بيبقى عندنا integral of dr. Now how much is dr? dr is simply r multiplied by d theta. We have seen last time that dr in this case لما تكون عم تحكوا عن infinitesimal displacement along a circle، dr هو نفسه ds, where ds is the infinitesimal arc of circle. أو ال ds نحن بنعرف من by definition إنه it's equal to r times d theta. So it's integral to r times d theta, and theta it goes from على البوينت B الثيتا هي كانت صفر لأنه البلوك كان هون، فبالتالي the angle between هيدا اللاين اللي شايفينه مع اللاين الهوريزونتال هو صفر لأنه هو كان coinciding معه. أما لما يصير فوق بتكون الانجل ما بين هيدا الهوريزونتال لاين واللاين اللي بيوصل السنتر على البوينت تي محل ما موجود البلوك هو عبارة عن باي. So this is why it's between 0 and pi. And r is constant, it gets out of the integral. We end up with minus f times r times pi. So we have the work of the friction force. Let's replace it by its value. Delta k plus delta u is equal to wf. The difference in the kinetic energy هي half mv t squared minus half mvb squared plus mg times yt minus yb. إذا أخذنا yb هي الصفر، بيطلع معنا إنه yt هي 2 times r، هي عالية عن النقطة B 2 times the radius. So this is equal to minus pi r f Now we can cancel m on both in both terms of the on the left hand side of the equation, and then divide by it on the right hand side of the equation. إذا بدنا نختزل هون الm لازم نقسم عليها من ثاني جهة لحتى نكون consistent. بالاخير بشويه manipulation بيطلع معنا انه ال vt the speed at the point t is given by 4.1 meters per second. So this is it for this problem, and this is it for the chapter 8. I will ask you to solve these problems without having a look at the solutions at the beginning, and then you can have a look at the solution to correct for yourself.